Yeah, it's not that like important, but of course it would be nice sometimes. Like you have the culture that you actually go to the pubs and meet people, which is quite nice. But here, I don't know where people meet people, or do they want to meet people, or do they just want to be alone? I like the pubs a lot, because like you can just go and people are friendly and it's a nice atmosphere. It's warm and everybody can like go there, the whole family and
I found that like from the UK.
yes.
From the school, like
Yes.
I don't know here, it's just more expensive. So like
Yeah, it's also more expensive. That's true. That's also true. Then we also try to go sometimes with some work people that a lot of younger people. But then it always feels a bit like we try to go somewhere, but it's a bit like, well, it's nice, but then it's quite like dead there. So you try to find some meaning is some like, place where something happens. You can't.
you have a lot of nice out then. Like,
What?
go for drinks with work people. Like,
Yeah, we try sometimes. And now next week's Friday, we have some kind of like organized, like a bit like a pikkujoulu thing. Paid by the, this bank, and there's some kind of official thing, and then there's some food and I think most probably even drinks and some kind of a band. Yeah, that's quite nice. But then it's of course like, well, but thankfully it's Friday because sometimes these things were happening also on during the week, and then that's a bit like lame.
Yeah.
So then you don't have to like be at work next morning that early. So okay. I'm obviously already even recording. This was very important things to record. So we were in the mid-term exam one, and many of you did it like really, really well. Like for most of you, it went really well. So 1A, it's this, and this is super easy, of course. Yeah, well, maybe we don't have to go through that. 3x minus 7 is 2x plus 5. And then you would just move the terms. So for example, you get x is, well, you get immediately actually x is 12, don't you? Just like that. Yes, cool. Then the next, and you did there something like minus 2x plus 7. Yes, and you get, I think everybody got this correct. This was a bit more complicated. The next, maybe. So you have 4 minus t divided by t plus 1. Yeah, and this was, of course, the 2 points, which is 503. So then you can do many things. And for example, the cross multiplying. So you multiply this with this and this with this, or one step at a time. So first you get rid of this or rid of this, and then next the other thing. Well, or many things you can do, but I will do, for example, like this. I will first get rid of this t plus 1 because that doesn't look nice there. So I get 4t is 503 times this t plus 1. Yes. Then I get rid of the 3. I don't like to, this cross multiplication is exactly the same. This is just done with 2 steps. So then I have 3 times 4 minus t is 5 times t plus 1. And here some things might happen, like you might think that you can take something from this kind of form first, but you can't because there is like with this, you just have to get first rid of this denominator. And then you can start like you can't remove any of these terms, somehow move them somewhere or whatever. These kind of things might easily happen there. So okay, so then if I have something here, then I of course have to multiply both with it. So then I get 12 minus 3t is 5t plus 5. By the way, if you did this like really well, and you can still continue, you don't have to. I just go through this. You can continue to what you need to do, basically. But if you want to check your exam, I just go quickly through. I don't know how quickly, but at least, yes. Okay, so I have to multiply both, of course, with the 3 and also the 5, the both things that are inside the brackets. And then now this looks pretty similar to this, yes. So then I can proceed the similar way. I want the t's to the left side, so I would subtract minus 5t. I want it away from this side, and then I would subtract maybe also the 12. And this is not that you have to do it also in this order, but this is one way. Okay, so I get here minus 8t in total, yeah? And on the other side, I get 5 minus 12 would be 7. Minus 7. And then I still have to get the t alone. So that's what I always want. I want to have this here alone, so I then take this minus 8, which would be then minus 7 divided by minus 8, which would be 7 divided by 8. Do you want to ask if something happened there with your exam? You can also ask if.
When I was done, I got in my mind of, t divided by t would become 1.
Yeah. But you can't. Why can't you do it here?
Yes, because t plus 1 is 1. Is that right?
Yeah, because first there's the order of operations. So first you have to conduct the division and the multiplication, and after that you can do this kind of operations like subtraction or addition that are here. So you can't, when you have here addition or subtraction, you can't do anything to that before you did the division. So you're not allowed to, from this kind of sentences, to take anything. That would be different if you would have there. If you would have there, like 4t, yeah?
Yeah.
And here you had like 1t or whatever t.
Yeah.
And this would be something. Then you could, of course, now you are already, there is multiplication and division sort of going on.
Yeah.
You can take this.
Okay.
And you also know this Bigger's yes. So then you would just get 4. There's maybe many ways to think about this. Here you could also take the t out if it would be multiplying something, but then you would have to get it somehow like t is multiplying something like 4 minus 1.
Yeah.
And then here t is multiplying something like whatever, 1 plus 1. But that would mean that your sentence would have to be 4 t minus t, for example. And why would you have it anyway like this?
Yeah.
Yeah. But like, so then you can take a common factor.
Okay.
Whatever. Yeah, but these are the things that happen a lot, in
Yeah.
this kind of, that something happens, and then this is also, I guess, with the physics equations, you have to know
Yeah.
basically how to operate this kind of how it actually goes. Then the next one was really easy, yeah. Yeah, that you just put there something in the place of x. I think everybody knew, so I'm not maybe gonna say anything about it. You just stick this number there where is the x, and you get the result. Yes, good. Then line, the equation of the line, and the graph and the slope. Okay. So you had the points 2, minus 1. I'm not sure if I have now my equation book again. No. Maybe I could borrow. Thank you. Maybe it's the easiest with this. So then we had this. For example, here, this one is good. If you want to get the line equation, you get from this technical formulas, y minus y1 is 2 minus y1 divided by x2 minus x1 minus x1. Okay. Obviously, with 2 points, you can. So these could be, for example, x1 and y1, yeah. And these could be x2 and y2. Looks good. And then you can either put everything there immediately or first solve the k, whatever. So I will maybe just put everything there immediately. So the y1 was -1, so I could get y plus 1, and then y2 was 5, and y1 again that, and then x2 was 6, and x1 was 2. X minus 2. And there's many ways of doing this, but this is one way of getting the line equation again. So then I get y plus 1 is here is 6 and 4, x minus 2, and then again I will take the 2 out from here, so this would be 3 and this would be 2. Y plus 1 is 3 divided by 2 times x minus 2. And then I still have to multiply x minus 3. Yeah, so I get to multiply this with the 2, so I get -3. Maybe I have to check that out. Yes, and then still I have to have the y alone here to get the line equation, so I take the 1 out. -4, and then I just draw the line. Yes. So I need a little bit of space. Maybe even like this. Maybe I could draw it here. Was -4. Okay. So then this is the way, if I put that x is 0, which would be here, then the y is of course -4, which would be here. -4, and then I go up 3. So this is the change of the y, like you see from this form, for example, and this is the change of the x from the same time. So if the x changes 2, the y changes 3. Yeah. So then I can draw the line. And then I could draw the line also by just choosing those points, putting those points here and just drawing the line as well. Here is already the 0.2 -1. And now I don't have in this the 6, 5, because I didn't draw it that big, but you know, there's many ways drawing the line, and then you can mark here that here is the changes 3, and here is changes. This is 3, and this is 2, and this is the y-intercept. And here is something like this. Yes. Pretty simple. Then solve the angle, solve the components. Yes. This one. That is question mark. So then I check something. For example, from the equation book, if I don't remember. The right triangle, and then I can see that. Well, I know some angle there. There's the angle. So I seem to know those these shorter sides. What are they called? And then it's the hypotenuse, or what is it called?
Yeah, the hypotenuse.
Hypotenuse. And what are these?
B is the adjacent and A is the opposite.
Yeah, but do you have some name for them?
Yeah, opposite and adjacent.
Yeah. But is it some, it's not hypotenuse, but it's like
Well, I don't know.
side maybe?
Yeah, I don't know the opposite.
In Finnish, we have something for that, but I don't know in English. Okay. So then we see that if we know these sides, then obviously we have to use the tangent, yes. And it was the opposite. The opposite here is 6. And the adjacent is 3. Yes. Which seems to be 2. And then, so we get the tangent is 2. And then we have to take this from there. And just put it into the calculator. That's it. I think very many of you were able to do this, yes? And it's also something that's pretty familiar from somewhere where you did this kind of things early in some school. It 63, yes. Then there's a truck. Have you been doing this kind of calculations now in the physics?
I don't.
Or you've been dividing force into components, maybe? Or no?
I think I remember something, but
That can be a truck.
that's fine.
Downhill. Okay. And then we had the G here. And it had to be divided into components, yeah? This is still pretty simple. And many of you had been solving also this. So this would be the GY, GX, and the G. Just like that. And so all the components, I know that here is the 5-degree angle. Then there was the equation G is mg. And then I can think from there somehow. I can write, for example, like this. Sin 5 is the opposite divided by the G. So obviously the GX is G times sin 5. And the cos, which is the adjacent side, is the GY divided by G. Yes, because our angle is here, the 5-degree angle that we also went through. Why that's the 5-degree angle. And then you just put there the what were those. So if I want to solve the numbers, then I just put the mg. The m was kilograms. This is 9.81. And then here, sin 5, and then g, y. The same. Does this seem okay to you? It's fine. And then the last one, well, these were all 2 points. 2 points. I don't remember if I marked. But the last one was only 2 points as well. Many of you didn't really know how to do it, but it doesn't matter. It's more like physics.
Remember
Maybe I don't go through it now, or you can do it in physics then. Yes, we went through it, and that's fine, but that was just one application. Okay. So the C 2 points, and if you were able to do it, most probably you would have been doing it somewhere else but here as well, yeah, in some other school, because maybe we didn't do that kind of calculations that many that you would have actually then learned to do it, yeah. But that was only 2 points anyway, yeah, so it doesn't make a big difference. For building plan drawing scale was 1 to 75. Rectangular hall has measures 84 millimeters times 60 millimeters. Actually, well, yeah, of course I could have it here. Put it again like this. So there's the scale, measures, actual dimensions, and floor area. Yes. So this meant that 1 millimeter on the drawing is 75 millimeter in nature. Yes. And then we would have to multiply them both with 75, yeah, to get the measures in nature. Multiply with 75. So this 84 times 75, and this would still be millimeters, is, and 60 times 75 millimeters is, and then the area is, of course, then those multiplied. This was pretty simple as well, yeah?
Yeah.
Was it simple?
Yeah. Don't understand why I just have done from start.
Millimeters. And then so this, if it's a millimeter, then to get it in meters, so this would be millimeter, centimeter, decimeter, and meter, yeah? If you want it in meters, but you don't have to you can also have the millimeters. And then the area is, of course, the side multiplied by the other side. Meters. And that's it. This was 3 points. The whole thing. Okay. Next. Tree fertilizers. This is exactly like we had some exercise, yeah, but there's just a booster. That's that time we didn't have some booster. Percentage on of the final blend. Okay. Nitrogen. So I have to know how much. For example, the mass is them all together, yeah? I think like most of you also did this really well. This was kilograms. This is 900, yeah? Then you have to know how much was in each. So then you have 28% in this total mass. let's say it like this. Nitrogen. Nitrogen mass would be then 0.28 times 250 plus 0.18 times 500 plus 0.4 times 150. This is also in kilograms, which would be then something. So this was about the percentage or percent, what it means basically, how you calculate those. Oops, there's no. $220. And then, okay. This then, of course, this divided by this. And then you can multiply it with 100, or then you just get the hundreds from here. Oops. Is now correct. Yes, it's correct. I didn't check. Well, now I've got many. Here's also a point. Well, maybe in other countries you can put many points to many places, which is about 24%. I didn't make any mistake there calculating, did I? Didn't check now. Well, most probably not. Nobody's saying any. It was correct, yeah. Then 5. Solve and draw also the lines. Woo. And then there was many ways of solving this, yes? Plus, but not with the Excel that we also tried, because we didn't have the Excel, we couldn't use it, yeah? What would I do here to solve this? Maybe multiply this with 2. Maybe. This is one way of solving this. Was this an easy exercise?
Yeah.
Did you get it correct?
Yeah.
Okay.
Draw them.
You didn't draw. Yes. So you okay. So then I would how I mark like this. Or like this maybe. Okay. So I get calculate, no, plus. I just put the plus there. So then this is 5. And then here I have 0, why? Yeah. And then I have minus 20. Mm. 5x is 20 and x is 4. Is this correct?
Yeah.
Is correct, yes. And then I just from any equation I can just solve the y. Take this x into, for example, there. Stick it there. 4 minus y minus 2 is 0. And y is minus 2. No, 2. Yes. It was 2. Yes. Okay. So then I got those. Draw also the lines. That was more difficult because they were in this kind of a form, or not really. So I need just, if I want to draw the lines, I need those. Draw the lines. I need those equations in the solved form. So this could be 1 and this could be 2. So I have 1, which is 3x plus 2y minus 16 is 0. So I have to have it, to be able to draw it the way that we've been drawing it, I have to have it in the form y is something, yeah? Okay. So if, for example, if I have now 2y and I put the rest to the other side, so I have minus 3x plus 16, yes? So this is still on the left side, and the rest I threw to the other side and changed the signs, yes? Okay. And then I just divide by 2 to have the y alone. Plus 8. And then the 2 would be a bit more simple, yeah. So I need to have the y alone. Minus y is minus x plus 2. And then I have to change the signs or divide by minus 1 or whatever, what I'm doing here, yeah. Y is x plus 2, minus 2. Somebody correct me if I'm doing something wrong. Yeah? No, it's fine. So then I have to draw them. Draw the lines, and I will have to have quite a lot of space here. Here the 8. Minus 2 would be like there, and I put that. And then I can start. So I have plus 8, and I have minus 3 divided by 2. So I go down 3. So should I have this somewhere here? So I had to have space for this because it cuts the y-axis at 8. And then I go down because there's a minus sign, and I go down 3 when I go right 2, yes? Like this. So I always go down 3 when I go right 2. Seems correct? Yes, makes sense. Okay, and I would even need to have the cutting point at what was it? Let's try to draw this pretty okay. Looks okay. Wow. Next, I was in -2. And this is y is x -2. So I have just moved a very simple line down to 2. Just like that. I think I'm also getting the cutting point right. Wow. I could have also done this, but I needed to solve the equations. Yes. So here was the point for 2. Now we at least know how to draw the lines and things like this. And what is the line equation? Because this is like just the simplest equations that you can have. Y is x, and now I just put it down to, because I had y is x -2. Yeah. So this is how it works. Then the B. This takes ages now. My going through this. But I hope you have found yourself something meaningful to do in the meantime. Playground perimeter. Perimeter meant so that you walk the whole way around it next to its walls or something like this. Yes. 83 meters. Then you had many times. So this is the width and this is the length, if we want to mark them like this. Width times length is 84. The length, this, is 3 meters less than 3 times its width. So the length is 3 meters less than 3 times the width. Yeah. This is quite simple. Does it look correct? You got the same?
No.
Somebody? Yes.
Can I ask, why is width and length the perimeter?
No, I'm doing this. Thank you. Now I'm doing this. This is correct, yes, but this is not. Length. What should this be here?
Well, I've got the wrong. So
Tell me.
Um,
Now I already told myself what the perimeter means, but then I still thought that it meant something different.
we're in.
Yes.
Yeah.
Okay, so how you would formulate it?
I thought I've done it wrong. So.
What do you need there? You need two of these and 2 of these, yeah.
Yeah. Okay.
Yeah, exactly. So 2 of these plus 2 of these. Of course, if you go around it. Yeah. I'm going here and then here and then again. And that's the perimeter. Now this is correct. So still the length is 3 meters less than 3 times the width. This is correct as well, yeah? And now I could solve it. So now it would make sense just to stick this here, yeah? Because I have already this solved here, so I would just stick it there. There. 2 plus 2, and then here would be this equation is 84. Okay, and then I would just solve it. So there's, I again have to multiply both here. Yes, 6 and minus 6 is 84. And then I get 8 is 78. No, now I'm going too fast. It's funny, I have in my head, there's always a song for every situation. So then if I say something, it's again the song there. There's a song of going too fast, but that's from my youth. Okay, so I have the plus, so it's 90, yeah? Is this going correct now? Anybody checking? Did you calculate this?
No, but I didn't use an equation at all.
You just thought it through somehow. Other way. Yeah, you could have told how you did this. It would be a lot more interesting than this. Yes. But it looks like I'm doing it correctly, yeah? What was the answer? Yes. Everything fine there. So then I just get whatever. I sometimes doubt that when I calculate in the head things that they actually go correctly at all. And then of course, when you get 1, then you know the other because you know the dependency here, yes? So I know that length is 3 times width minus 3, so I can easily also solve it. 3 times 11.25 meters minus 3 meters, I guess. Times 3 and minus 3. Wow. And now I solve everything. Except the physics task that some of you knew, but maybe it's not the main thing on this course. Okay. You're happy with your exams? Did you check if I calculated the points correct? And you can also complain if I didn't.
Yeah, but understand there's like 4A. I just thought for some reason.
Yeah, but that sometimes might happen in the exam as well, that you don't realize that there was still something to do.
Could I see here? Why do you know that L is 2?
Here.
Yeah.
In this equation.
Yeah.
Because it was the perimeter, yes.
Yeah.
Okay, so the whole perimeter, this was the perimeter.
Yes.
There. So the perimeter, you have to, in perimeter, if it's a rectangular thingy, you of course have 2 of both sides.
Yeah.
2 of both sides
to
actually get around it. Yes?
Oh, okay. I get it. I was thinking it was just L. Okay.
If you also explain these things better in English than me, then you can also, if something, you can also explain it.
Would it be possible? Like, do put the exam on, no, is that okay, or,
The exam, yeah, this.
yeah. You,
So you would see how it looked, how it was.
yeah, so I could,
Yeah, why not? Because I don't have, when I gave it, I let people to take it. Of course, it means that I can't put any same exercises into the
yeah,
examinarium exam. Well, with this, it's quite easy to place them because it's just very simple, simple maths. With some other courses, it's not that easy.
yeah,
There will be some same exercises as well. Most probably at least some.
yeah,
So then that I can't really do that,
yeah.
But now I can. So I could put this document and that there. There's only one thing missing. That force calculation that's of your own. Depends on your own interest if you want to, basically.
I spent so long with that, I could remember the same thing in class. I remember going through it, and then it's like, it's like almost there, but you quite see it.
The forces.
Yeah,
But then if it needs to, that if you go through it in the physics as well.
yeah.
So then you will realize what's going on there better. Okay, but we were here now still, and this is also the topic of this week. So we are not, because what do we still have? Could we use a little bit more time for this? Because now I went through this for ages, the exam. I was even thinking that I could go through some kind of proof of those sin and cosine. But you can, for sure, some of you are familiar with those. Who has done the proofs of the sin and cosine? What are they called? Sin and cosine laws. Where are they here? In school. You? Lukion pitkässä matikassa varmaan olette. Siellähän käydään aika paljon todistuksia. Joo. Where are they? They are here. Sin and cosine formulas. Oops, now this is somewhere else. Sorry. It's here. Okay. Because there is some kind of a proof of the sin formula. For sure, you can find many YouTube videos, somebody going through this really smoothly. Would you like to go through these proofs here? How you get these equations? Yes. So, but maybe now we don't have, maybe now we still calculate on the next lesson, I will go through this. And then I will ask you to do this. And then you can do it the way you want. You can ask the AI or the YouTube as well. And then somebody of you could show it here for everybody. Would that be nice? Or would that make any sense? Does that sound like something that we should do here? Okay, let's do it. So let's now use the end of this lesson just to calculate these exercises that are still there. I could also show those solutions there already, because we have been on this topic since Monday. And then on the next lesson, we still go through the proofs and if we need to go through the exercises as well. And the geometry, we will continue then in the beginning of engineering mathematics too. But those exercises there are a bit more difficult maybe. So this was just with the sine and the cosine formula. We went through these on Monday, yes? And we went until, yeah, and here's it, because this is different, this translation to this exercise that it originally was. So comes a bit different answer. This is actually correct, the one that the AI made. And this is not. Well, whatever. You just needed two triangles and to use the sine formula. So then maybe you already, I think we calculated this as well. Yeah, the 5, didn't we? On Monday, maybe. Have you calculated all these already? Are they easy? Not bad. Who has calculated exercise 6? Yeah, we went until 5 on the exercise 5 on Monday. So then we could continue from the 6. Yeah, on this side. This is where we ended. So there's some kind of situation of, I guess this tries to be some kind of it looks even a bit like professional thing. And you have something coming here. So here's the alpha. Here is 58. 58. I know that the length of this is 50. And this is 140. Okay, I think this was pretty simple. You just have to basically, yeah, it's simple. You just have to know this, yes. But if you know this already, it's easy to solve this. here. So you just have to draw it to the right angle triangle. Yes? Right triangle. English is actually really simple language. I think Finns say things a lot more complicated way. And the English becomes a bit more complicated as well when a Finn speaks it. So it's not right angle triangle, it's right triangle. Yes? Yeah, what can you do? That was 58, and this is, here would be a straight angle. So, and then I would definitely know this if I know this side. So I know that I need the opposite, yes? Sin 58 is the opposite divided by the 50. Yeah? So the x would be 50 sin 58. And then, well, okay, I can take that value. Something. So now I know that it's 42, about 42. Ootteko tulossa jo?
Mä katsoin, että mun tietokoneesta mikä se luokka on.
Joo. No niin, ja teillä alkaa tasalta.
Joo.
No niin, hyvä.
Ei minuutin päälle ole. Tämä on loppuun vaihdetaan.
Yeah, so it's this page here again. So now I know some things. I know this and I know this. It seems that I know the C and I know the A. So again, I have the same. Most probably this could have been solved some other way as well. It's the about 42.4 something divided by 140. Yeah. So then the A would be the 10 minus 1. 4 divided by 140. Yeah. And that would be something. And this is how much we managed to do this topic on this lesson. 10 minus 1. Here I have the answer. And here I have that. Is this correct? Yes. Something about 17. How correct were these? Maybe it's 17.6 or 18. Oops, now it looks like I don't have the. So should we continue next week with the what I promised, the proofs?
Yeah.
How nice is that? Okei. Thanks. Ihan perusmatikka.